Welcome back to Discovering Geometry with Mrs. Berry. This is Lesson 56. This is the start of Chapter 9, all about the Pythagorean Theorem. Today we will label a right triangle, we will learn what the Pythagorean Theorem is, and we will do some problem solving. Here is a right triangle. We label the legs as the edges of the triangle that come off of the 90-degree angle. So there are two legs to a right triangle. We often label the legs with a small a and a small b. The hypotenuse is what we call the longest edge of the triangle that's across from the 90-degree angle. The hypotenuse is always the longest, it is always across from the 90-degree angle. We often label it with a small c. So which side is across from the right angle? The hypotenuse. Our investigation is going to talk about the three sides of a right triangle. You're going to construct a scalene right triangle in the middle of your paper. You will label the hypotenuse C and the legs A and B. Then construct a square on each side of the triangle. To locate the center of the square on the longer leg, draw its diagonals. Label the point O. Through point O, construct line J that is perpendicular to the hypotenuse and line K that is parallel to the hypotenuse. Then lines J and K will divide the square on the longer leg into 4 parts. So you'll have something like this. My drawing's not going to be real great here. And then perpendicular to that, so somewhere along here. Then you will cut the square on the shorter leg, this one right here labeled A on mine, and then the 4 parts of the square on the longer leg. Then try to arrange them to cover this square that's off the hypotenuse. So here's what my drawing looked like after I cut that longer leg square. And then here I cut across the pieces, and let's see what it looks like. So trying to arrange these and figuring out exactly how they're going to fit inside this bigger square, the square that's on the hypotenuse. Then I have the square from the little leg and the last 2 pieces from that longer leg. And isn't that fun that it fits exactly in there? And what does that mean? So if this is the length of the shorter leg, then the area of this square is A squared. If this is a length of the longer leg, then the area of this big square is going to be B squared. A squared and B squared all fit inside of this square, which off the hypotenuse is C squared. So the Pythagorean theorem, in a right triangle, the sum of the squares of the lengths of the legs, or those squares that came off of them, equals the square of the length of the hypotenuse, or that big square that we fit everything into. So if A and B are the lengths of the legs and C is the length of the hypotenuse, what is our formula? Well, we had that small square plus the bigger square. Though we cut that bigger square into 4 pieces, it was all still there. It all fit inside of the hypotenuse square, or C squared. So the Pythagorean theorem is A squared plus B squared equals C squared. What's the difference between a conjecture, which we have been doing, and a theorem? Well, a theorem has been proved. And there are actually many, many proofs to the Pythagorean theorem. More than 200, in fact. So the Pythagorean theorem works for right triangles. Does it work for all the triangles? Let's imagine in this first picture we have a right triangle. Let's keep the legs the same and just push this in so that there's no longer a right angle, or pull it out so that it's more than a right angle and an obtuse angle. So if we pull it out, now we have an obtuse angle down here. These legs stayed the same, but what happened to the hypotenuse, this blue line? It got bigger. So is it now still possible that a squared plus b squared equals c squared? No, c squared will be bigger. What happens if you push this side in and make that right angle now an acute angle? Well, we have made that former hypotenuse into a shorter line, so the Pythagorean theorem will no longer work. In fact, c squared will now be smaller than a squared plus b squared. Let's do some examples. A 26-foot ladder is leaning against the wall as shown. If the top of the ladder touches the wall 24 feet up, how far away from the wall is the ladder on the ground? So we're trying to find this distance. We know that the ladder is 26 feet, and we know that it touches the top of the wall at 24 feet. We're going to use the Pythagorean theorem. This leg on the ground is 1, and this height against the wall is a second leg, and then the ladder is our hypotenuse because it's across from the right angle. So we will have, I'm going to call our unknown a squared, plus b, which is 24 feet squared, is equal to c, which is 26 feet squared. 26 times 26 is 676. 24 squared is 576. And then we still don't know a squared. We're going to subtract the 576. Now we have that a squared is 100. And hopefully you know what that is, but we can take the square root of both sides. So the square root of a squared is now just a. The square root of 100 is 10. Actually, when we're solving, the square root of 100 is going to be plus or minus 10. But since we are looking for a distance, it has to be positive. So a is 10 feet. Our last example. We want to find the area of the rectangular rug if the width is 12 feet and the diagonal measures 20 feet. So the diagonal is across from corner to corner. That makes this part a right triangle. So half of it cut by the diagonal will be a right triangle. That diagonal will be our hypotenuse, or our C. Up here, the 12 feet is maybe our A, it's the shorter one. And then the longer one will be B. We're going to need A and B to find out the area of the rug. So let's see if we can solve for B. Remember, our Pythagorean theorem is a squared plus b squared equals c squared. For A, we have 12 feet. B is our unknown. And for C, we have 20 feet. So 12 squared is 144. And 20 squared is 400. If we subtract 144 from both sides, we get 256. Now we're going to take the square root of both sides of this equation. That leaves us with b, and technically it's plus or minus the square root of 256, but we know that we're only looking for a positive here, so the square root of 256 is either plus or minus 16, and we will just take the positive one. So 16 is our length for B. Now, to find the area of the rectangle, we're going to multiply 12 times 16, the shorter side times the longer side. That gives us 192. Both of these were feet, 12 feet by 16 feet, so our area is 192 feet squared.